Okay, I think we can start. Good morning and welcome everyone to this CMCC webinar of today. My name is Johannes Emmerling. I'm a researcher at the RFF-CMCC European Institute on Economics and the Environment in Milan. And I'm very happy to present today's webinar by a colleague of mine based in Venice, however, who is Lorenza Campagnolo, who will speak about distributional consequences of climate change impacts on residential energy demand, with two different approaches applied to two countries. Lorenza is a researcher at the RFF-CMCC Center in Venice and also of CMCC, and she's also a researcher at the University Ca' Foscari in Venice. Before we start, just a brief introduction about CMCC. For those of you who maybe haven't heard about it yet, CMCC stands for the Centro Euro-Mediterraneo sui Cambiamenti Climatici, so on the Euro-Mediterranean Center of Climate Change, with focusing a lot on climate change, the climate system, and interactions with society. So really focusing on these impacts of climate change and interactions with the environment and human society. We have CMCC has offices in around all basically regions of Italy. Here you can see the main offices with different focus and different disciplinary approaches and methods to be used. There's also a lot of institutional partners, which are partners and or members of CMCC, which include a lot of universities from Bologna, Polytechnic in Milano, Venice, but also other universities around Italy and some international partners, especially also the Resources for the Future in Washington, DC. And as said, CMCC has a widespread approach in terms of environment and economics and climate change. So we have here, you can see the main divisions, which are focusing from oceans to climate models, in agriculture and ecosystems, and then climate and the economic analysis of climate change. And today's speaker is from the economic analysis of climate and impacts and policy division, which is based in Venice. One core activity also of CMCC is the use of a supercomputing center, which is based in Lecce, and here you can see a couple of details. It's one of the big computing centers in Europe, used for anything from ocean modeling to climate modeling, including meteorological forecasts and also economic modeling. So it's used for a variety of the works that we do at CMCC. And finally, of course, as a scientific organization, our main goal is also outreach to the community, the scientific community, through high-level publications, also contributions to master and PhD program curricula, and then the organization of events and outreach activities to the general media, the general public, or interested clienteles and private sector actors. And this webinar series is one of these kind of events that we organize to disseminate our research and main findings in this field to a very broad audience. So thanks for joining us today. And just a few remarks. So we will have this Q&A session that you can see, which is active throughout the talk. So if you have any question, please post your question in this Q&A section, and we will then after the talk have time for the speaker to answer to it or discuss it. And in case, you can also raise your hand if you want to have a question, and I will give the floor to you so you can raise your question orally. Now, with that being said, that is it from my side. So just to remind you that this video is recorded, and you can find all recordings also of previous webinars on our YouTube channel and on the other social media platforms that we also use. So please have a look at those. And with that being said, thanks a lot again for joining. And Lorenza, the floor is yours. If you can share the screen, that should work.
Thank you, Johannes, for the kind introduction. And you should see, can you see the screen?
Yes, perfect.
Perfect. Thank you so much. Hello, everybody. As Johannes said, Sorry. Here we are. As Johannes said, I'm working at the ECIP division at CMCC and also at the Campagnolo University. My work today, my presentation today, it's kind of try to put together the work of the past years. All the work have been focused on climate change impact, a specific type of climate change impact, which is the one on energy demand, especially for residential, and the research question is try to understand not the global cost of the climate change, but not the regional cost of climate change, but try to look more in detail at what is happening, what will happen at household type level. So the distributional consequences of climate change are analyzed to a lower level of detail, to a higher level of detail. As I said, this presentation tried to put together two work done with the two different methodologies and applied to two different countries. So the motivation of the work is the following. We know that climate change will induce more frequent high temperature extremes and less frequent days with low temperature. So the climate change will imply a change in temperature. We are not really looking at the mean temperature. We are looking more at the persistence of a high temperature, which is measured, or the persistence of low temperature. These two dimensions are measured with two indices, in particular the CDD and HDD, the cooling degree day and 18 degree days. So basically these indices assess the variation from the comfort temperature in the current time and also in the future. So if it is the temperature is higher, persistently higher with respect to the comfort temperature, we will call it the indicators the cooling degree days. The opposite is instead for the 18 degree days. And basically these indicators are linked with the fact that energy is needed for cooling, this CDD, and energy is needed for heating in the case of the HDD. So as I said, energy is one sector that will be directly exposed to climate change. If we think about demand side, so household families, we know that people will adjust their energy behavior, their energy demand to cope with the weather shocks. Less energy will be used in the future for heating, because we expect an increase of temperature persistency of hot spells. And on the other side, we expect less energy will be used for heating. The idea of this work is to understand what are the implications of climate-induced energy demand shocks on inequality and especially on energy poverty. So what will happen to different types of household in their attempt to adapt to the future climate change using energy. As I said, the research question will be addressed with two different methodologies in two very different countries, Italy and India. So the literature analyzing distributional implication is quite wide, but it's analyzing distributional implication of policies such fuel and carbon taxes. So the distributional implication assessment is more focused on policy and mitigation policies or fuel policies. What is observed in the literature is that direct impacts are in general regressive, but there are several differences on the regressivity or progressivity of the impact, and the differences are depends on the type of fuel. For example, electricity is found more sensitive than the other fuels to the climate change, to the change of price. There are differences also regarding time span, which is considered in the long run. The elasticity, the demand elasticity, it's higher, so it's less. It's the impact on different households. It's observed to be less strong and less aggressive. The impacts are also, the magnitude of impacts also depends on the welfare measure, which is used, income or consumption. But what is generally measured, especially in empirical works, is the direct impact of energy demand. But this is only a first approximation of the overall shock effect. The change of price, in fact, it's only the first direct impact. If we consider, for example, a macroeconomic assessment, we see that the price increase determines adjustment to all the rest of the economy, on the choices of firms, on choices of household regarding that goods. In this case, we are talking about mitigation and therefore energy goods, but also the choices of household regarding the other goods, the other commodities are adjusting to the first shock. This kind of analysis, it's usually so considering direct impacts and indirect impacts of a shock. These are used in a macroeconomic framework. These are assessed in a macroeconomic framework. Another aspect, most of literature has focused on vertical equities. So the distribution of impact across, for example, different deciles. There are less studies analyzing horizontal equity impacts. Horizontal means, for example, households that are similar regarding the income, but they are quite different regarding the preferences, housing characteristics, and regional and location, for example. We are trying to address also this part in our work. What is less studied, what I've talked up to now, it's more relative to distributional implications of a policy, of a mitigation policy, of a carbon tax. What is less used and what is less analyzed are the distributional implication of climate change impacts. As I said, we are trying to consider, we want to analyze the distributional implication of climate change impacts. And we are looking also at the literature, at the modeling literature, which is able to combine the assessment, the first order level assessment, and also the higher order assessment. So trying to consider all the interactions that follow a shock, and not only the first impact. The macroeconomic modeling frameworks are suitable to account for these higher order effects of a shock. And as it's explained by Barwoven, usually in this kind of analysis, a CG framework, a macro modeling framework, it's used. But what is this kind of framework as a problem, because it's a regional level and also the results are at a regional country level. There are two options to consider the distributional, to have a distributional assessment. And the first one is to introduce detail from household surveys inside a model in some of one region, and derive directly the assessment of the shock for different kind of household inside the model. The other option is to use a microsimulation framework, so to and combine it with a model in order to describe the behavior of individuals after a shock inside a microsimulation model, and make them interact at macro level with a macro model, with feedbacks of top-down, bottom-up approach. It depends very much on, there are many examples in the literature. The approaches that we will use are two, and they are a combination of these two. In the first case, we will consider CG analysis plus a microsimulation analysis. That's our work, the work that we have done with Enrica De Chan for Italy. And the other approach is more work in progress, and it's considering a multi-household CG, so this kind of framework for India. So this is the methodological flow for the Italian case. So basically we compute, we upscale detail about energy demand to adapt to climate change, to an increased temperature at NUTS2 level for Italy. The database is global, but for Italy it is upscaled at NUTS2 level. The physical impacts are coming from the Johannes in 2017, and they are on residential energy demand. This shock on energy demand and also energy expenditure, so price shock and quantity shock, are directly imposed on Italian household survey of 2007 in order to assess a first order distributional assessment, to have a first order distributional assessment. On the other side, we consider a higher order distributional assessment. So basically the shock on energy demand is fed in a model with NUTS2 level detail for Italy. There are all the adjustment of the economy following this change in energy demand. They are further downscaled using the household survey. And in order that we are able to derive, to have an assessment, a higher order assessment of the distributional implication for household, regarding household energy expenditure, and also some poverty indicators. So the impacts, as I said, on residential energy demand are by fuel and by scenario. They're coming from panel data regression and from the channel ensuing. And we consider two scenarios, one of moderate, one of intense climate change. And these are the effect for three different fuel, electricity, gas, and petroleum products across Italian region. Under moderate intense global warming in period 2045-2055, Italian household will reduce the use of heating fuel for gas, so of gas and of petroleum products. We observe instead here an increase of electricity demand between 0 and 16% under moderate and intense warming. What's the state of the art? What is the condition of residential energy? How is a residential energy used in Italy? Energy expenditure, it's about 5% of all the overall household expenditure. The top decile will spend 3.4 times for energy than bottom one. And the share of energy expenditure falls from 9 to 3% across the decile. There are also some other information regarding energy use. 61% of the energy use is for heating, whether average AC ownership rate is about 28, air conditioning ownership rate, it's about 28%, with some regional exceptions. We consider two energy poverty indicators that count basically the number of households that are considered energy poor. So the first indicator is the actual fuel poverty prevalence index, which consider as poor households that have actual expenditure budgets on energy, which is higher than the minimum affordable budget share. This is the minimum affordable budget share, not to be socially excluded, and is computing using the median energy budget share of household below absolute poverty line. We consider another indicator, which is the potential fuel poverty prevalence, which try to consider only the expenditure in energy for necessary services. So it's basically try to cut off all the overconsumption that is measured with the actual fuel poverty prevalence index. So the fuel poverty prevalence in 2007, it ranges from 24 to 8%. So as you see, what we will look at is this potential fuel poverty index, which also gets rid of the overconsumption that is observed in all deciles. So basically we see, we only look at the first decile and at the potential budget share index. So we're using CG model, as I said, it's ICCG model, it's global, it's a dynamic recursive model. There's a specific treatment of energy nest. But for Italy, we consider a database at NUTS2 level developed by Standardi et al. So energy demand shocks at regional level are fed in the ICIS model. We observe a price and quantity adjustment in the scenario runs, and then this outcome are used to shock microdata in the microsimulation module. So two scenarios are considered, a moderate and a severe warming scenario. They are compatible with the physical shocks. There's a an additional scenario which considers that the moderate scenario also should imply certain level of mitigation. And we consider the effect for 3 different sources of so gas and petroleum product and electricity. So as you see, for adapting to climate change in Italy, basically all regions increase their use of electricity for air conditioning. The higher is the climate change, the warming is increase of electricity. We see also that the mitigation contributes to this increase of electricity demand expenditure. We see also a drop here instead of expenditure in gas and petroleum products that is stronger with the severe warming, but we see instead an increase of expenditure in gas and petroleum products in the mitigation scenario due to the increase of prices of gas and petroleum products due to the mitigation. The effect is quite heterogeneous for the overall energy. But we see especially an increase of energy expenditure, especially in the south of Italy. If we look instead at the distribution across decile, we see that electricity is it's a bit regressive, has a regressive impact, so it benefits the highest decile. Instead, it's progressive the effect on gas and petroleum products, and it's slightly regressive the effect on energy. If we think about the poverty indicators I described before, we see a moderate or intense climate change. We see that moderate and intense climate change will lower the number of energy per household by 371,000 with respect to business as usual scenario. We see a strong reduction of the number of heating fuel per household and a moderate increase of electricity per household. The effects of RCP of the scenario with the mitigation is that the number of energy per household are reduces less with respect to the case of no mitigation. We see that the effects to regional level are quite heterogeneous across the region. This is the effect on energy expenditure and Sicily. It's at risk, especially with also with a small change of a moderate warming. With the higher warming, we see that the effect on heating fuels is stronger than the effect on cooling fuels. So we see a better condition, but we see that many regions are sensitive to the price change of energy fuels due to mitigation. So that was the analysis on Italy. I will take a few minutes more for showing you the first outcomes of the work on India. As I said, the work on India, it's considering, it's basically the same approach, but we are considering a multi-household model. So all the data, all the micro data are fed inside a CG model, which is characterized in India by different household types. And so that's the difference. That's the two main references that are being used to create this model. This is ICE's multi-household model. So basically, we are considering we split government and household as in ICS-XPS, and we further split household in different types of household which receive receive the income from different sources and also from the government, from different transfers, and then they use it for purchasing and goods with in a different way. So these are the main equations that characterize the model. So the model, the ICS-MH model, it's both work on data for characterizing the base year and work on also on the modeling side of how behavior change across time. And so basically, these are the two main equations looking at household income and how household income is used. Household income is coming from endowments, capital, labor, natural resources, land. It's coming from transfer from government, interest paid from debt, domestic and foreigner, and other adjustment variables. And so endowment, transfer, all these variables, and also the expenditure, how this income is used for purchasing goods, all these variables are characterized at household type level, so at decile level. And then also there are some equations characterizing the future evolution of this variable. I will show you quickly the information that have been introduced inside the model, and the information is coming from the Indian Human Development Survey. Considers its national representative. It considers 42,000 households. We see that it's that the income per household is quite unequal. The Gini index, it's around 0.55. It's higher than the World Bank estimate, which is computed on expenditure. It's lower than the IMF estimate, which is instead computed on the financial income and also considering financial assets. This income, it's used these are the expenditure share depending on the decile. We observe, for example, that in the first decile, around 34% of expenditure is devoted to purchasing food, both in agriculture and of the processed food. We see an opposite characterization in the 10th decile, which more of income is devoted to purchase market services. Then there was we did a lot of work in characterizing, looking from the survey and deriving the income sources by sector. We see that most of the income in the first decile is coming from the agriculture. The opposite is in the 10th decile instead, we see that the most of the income is coming from the service sector. Then we also had to specify how the factors distribute across deciles. The primary factors are land, labor, capital, and transfers. So we see, for example, that transfers are the share of income coming from transfers are higher in the first decile and almost null in the 10th decile. On the other side, we see that skilled labor is strong and it's a big portion of the income in the 10th decile. So then we built a baseline scenario and that reproduce EMF 36 study with CO2 emission in 2050, which is coherent with RCP6. And so we observe from the model outcome that the average income growth is stronger clearly from poorest household than for richest households. We observe a small decrease of Gini index, so an improvement of equity, which is also showed by the Lorenza curve. So the income distribution is slightly more equal in 2050 according to our simulation. And then we shock we shock the energy demand in the model in order to assess the distributional implication. The shock, it's not really on energy demand, but it's on electricity demand, and it's coming from Campagnolo 2021, considering the effect of socioeconomic and climate condition. And it's, as you can see, it's slightly different across the sides, but it's about 5%. And it's differentiated, the shock is differentiated across the side to account for heterogeneity in household and appliance condition in the base year. This is the outcome. So basically we see a small drop and real expenditure of the first decile and a small increase of expenditure in the 10th decile. So the demand rise is concentrated on electricity and is strong for the top decile. But as you can see, also other sectors, all the other sectors are impacted. We see that basically the demand of all commodities drop. Instead, it's more heterogeneous, the effect on the 10th decile. We see the effect of using energy to adapt to climate change. On income, we see that it's very small, but it's not null, and there are not perceivable effects on inequality. To conclude, so multi-household CG approach versus CG plus micro-simulation model. So we try to evaluate the pros and cons of these two approaches in addressing distribution implication of climate change. In the first approach, the pros are the endogenous adjustment of household income and expenditure, and that is not true for the second approach. But on the other side, there's a loss of detail regarding the heterogeneity within the styles. And I think that maybe next step, I think I should stop here because I see Johannes, and I will give next step to the next presentation. Thank you for the attention. Sorry for taking for so long.
Thanks a lot, Lorenza. Great. No, perfectly in time, to the minute. Thanks a lot. Great overview, and I think a very relevant topic indeed, even more as we see energy prices all over the world changing as we see these days. So I think a very relevant work. Thanks a lot. And yeah, now please, if you have any questions or comments, put them in the Q&A section. Let me start with 3 that are there already. So one question is whether the slides will be shared. I think the presentation will be online, so I think there also you can then see the slides, of course. Okay, let's go to the first question by Andrea Cavina. So the question is, have you considered the role of hydrogen on decreasing fossil fuel demand and how this would differ in the households based on income and the deciles in this modeling exercise. I don't know, yeah, if you have a...
Sorry, I was unmuted. Okay, let's go one by one. So the present version of the current version of the model of ICS model is quite basic in the technologies consideration. We don't have hydrogen. We just have renewable energy sources, and so renewable electricity and fossil fuel electricity. Clearly, hydrogen it's a key technology to be included in this kind of model, and yes, it's a good idea to analyze the impact and the evolution of these technologies and the implication for different household types. I mean, I expect, yes, there will be implication on the price, the national price, and so basically lower lower energy prices probably, and but yes. Scenarios need to be built, and model need to be adapted to consider also these aspects. Thank you.
The second question is a bit on the household response. So how did you implement or assume the household response prices be across households? Is it elastic, and how is it varying? And also, how are fuels substituted? So what about substitutability between fuels? And finally, does not the energy infrastructure at the household level also impact this? And how did you consider that, maybe like install the devices, AC heating systems, etc.? Okay. 3 questions actually.
Yeah.
Bye.
Okay. The model is basically a macroeconomic model. So the starting point are economic monetary values. So I'm addressing the last question. So it's quite difficult to introduce information that you have, for example, from the survey about the appliances, the kind of the efficiency of the appliances or infrastructure that characterize the different household types. It may be possible, but I think it should be implied, could be only represented adjusting and estimating different elasticities for different households. At the moment, household expenditure responds to the same price and income elasticities. So they are at pricing income elasticity, they are at country level. There's a CD, constant difference elasticity structure for the expenditure side, and instead there is a CS structure from the production side. So there are different terms substitute all different factors. Primary factors in energy, and the specific with a constant elasticity of substitution. So that's the answer regarding the characteristic of the model. Clearly, it would be really interesting to characterize the response of the different type of households, also calibrating and estimating specific elasticities. but I mean, it's not yet done. Thank you.
Thanks. Yes, I think it explains it very well in this framework. And finally, a third question by Robin Morrison on that you introduced shocks to the model somehow, and whether you will be collecting and comparing current empirical data, how to help to calibrate and validate the model. So did you use some empirical data on the shocks? I guess referring to the climate scenarios probably that you looked at, right? You looked at the climate extremes. So I mean, did you use any?
So the sorry, yeah, I didn't get at it first. So basically, the shocks are estimated empirically. From in the first case from panel data regression, in the second case from repeated cross-section regression, and I was not really clear about this first step. In this first step, the change in energy demand is estimated on historical data, considering as a explicative variable both income, socioeconomic variables, and also climatic variable, the CDD and the HDD. So the estimation is run on the historical data, and then it's projected into the future, considering the change in climatic variable, but also the change in socioeconomic variables. What we take, it's only the change imposed by the climatic variables, and that is fed. So basically, the energy demand change due to climate change is fed directly inside of the model. Did I answer it on this?
Yeah, so I think it is calibrated, as you say. Oh no, sorry,
so
he's writing.
There's no calibration, it's simply the shock
estimation,
which is the shock estimated is exogenously imposed inside the model. It's an exogenous shock in the model, and then we see how all the economy adjusts.
Because yeah, he's specifying that he refers to the shocks as the price hikes, the price increase on energy. So, but this is coming from the model.
Yes, the shock it's on demand, so quantity used. Then the model adjusts the prices, and that's the
right.
The effect and the I mean the particularity of this approach to consider all the penetration of the shock in different sectors and affecting prices and also consumption of other goods.
Right. Yes. So it's an outcome, the price change, right?
Yes, the price is always the outcome inside inside a CGE model.
Okay, great, thanks. So that I think responds to this question. Yeah, please go ahead, type in questions, comments if you have, or raise your hand if you want to ask a question in person. I have maybe a quick one on the third last slide on electricity demand in India in the change across deciles. So I wanted to know what is so there seems pretty uniform increase on electricity demand across deciles, right?
Yeah, that's estimated. And yes, what we also were noticing is that the increase due to climate change of the energy demand it's not so high, and it is not so differentiated across the side. We were also concerned at the beginning about that. The reason that one of the reasons behind this outcome is that we are considering country energy demand. So we are losing all the detail about regional shock of energy demand and also regional increase of temperature. We know, for example, that in India, all the northeast will be strongly affected by global warming, instead of the south will be less affected. And probably this small energy demand change observed and also the homogeneity across the sites is due to the fact that the shock that we consider is averaged at a country level. It means also that yes, we are not considering the location of households in different sites, and it's also something that we will want to develop, try to considering that we know from a survey where the households are located, and probably there are many poor households that are from the poor region in the north. So we will try to differentiate and to aggregate differently the shock, taking into account the regional characteristic of future global warming.
Right. Yes. No. I think, yeah, also the last question is of course also looking at energy prices and effects, let's say these days. Would be interesting to look also on the price effect. Actually, there's one thing, what is demand in apart from the quantities also implies, and expenditure increases implies in terms of prices. I think that might be also interesting to look at.
I think we have more questions, Johannes.
Right, yes, there's, okay. So there's one on the renewables. Yeah, how the progressive implementation of renewables plays a role. And yeah, how do you calibrate the operational cost of renewables? So it is updated.
Okay. Yes, the different penetration of renewable sources may affect the price and the price change in the reference scenario. We are not considering, but we are planning to consider also a mitigation scenario to be combined, for example, with a low climate warming scenario. So in that case, when we also consider mitigation, and that will imply different and a change in penetration of renewable. For sure, it will be interesting to see the price change of, for example, of electricity due to renewable penetration in an impact mitigation scenario. And that would be really interesting. And regarding the second question, we are not really, the CGE model is not really working with cost of renewable technologies. It's not really working with the operational cost. We are, this kind of model is looking at how production is generated, and we are not considering operational cost. We are considering primary factor, intermediate factors, so capital, labor, natural resources. So the reasoning behind this kind of approach is pretty far from the one of, for example, the one of integrated assessment models, which are more grounded on the technology cost.
Yes, because there's also some, with the latest EIEE suggests quite some drops in the cost, which of course then can play a big role. So I think, it's good to make this assumption also. Probably they're going to be in the paper.
So our starting point is fixed, and it's the economy, and it's the value of production on renewable energies in a certain year. And then what we can work on efficiency and on efficiency use of different sources, and that's our only way to deal with lower cost of renewable sources in a scenario. But it's the reasoning is kind of different with respect to the integrated assessment models approach.
Thank you. Yes, good. The different model types, of course. Okay, great. I don't know if there's any further question. If not, I think we're also in good time for finishing this webinar on time. And thanks again, Lorenza, especially for preparing all these works, and looking forward to see also further works also, I think, on these relevant topics with other countries in the future, hopefully. And well, thanks to all for listening, and especially to Lorenza for being with us. And well, enjoy the rest of your day. And the video will be available made soon also in terms for the slides, at least visible there. So thanks again, and see you next time at the CMCC webinar.
Thank you.
Have a nice day.